At higher altitudes, ammonia crystals, or at lower altitudes, ammonium hydrosulfide make up the majority of Saturn's clouds. Atmospheric water clouds are also present at lower altitudes, occasionally resulting in storms. On Saturn, storms are significantly more intense than they are on Earth, though. Every 30 Earth years, the Great White Spot, a storm on Saturn, makes an appearance. The Great White Spot on Saturn first appeared in 1876 and has since returned every 30 years. Since it didn't resurface until 1990, NASA's Voyager probes missed the location when they flew through Saturn in 1980 to 1981. The Great White Spot vanished after 1990, only to return in 2020 as predicted. The second fastest winds in the entire solar system are found on Saturn. Only Neptune's winds have been observed to be faster, with Voyager probes capturing wind speeds of up to 500 meters per second. Despite this, it is still possible that Saturn's winds could be moving even more quickly. This is unquestionably one of the Saturn-related facts to be aware of. Cassini's moon. Some people characterize Titan as a moon that resembles a planet. Titan is 40% larger than the planet Mercury and 80% larger than the moon. Titan has a stronger gravity than other moons due to its larger size, which allows it to maintain a thick atmosphere. Methane and ethane are also present in Titan's atmosphere, which is mostly composed of nitrogen. As a result, the surface of Titan is covered in lakes of hydrocarbons similar to those found in gasoline and other fuels on Earth. Titan is especially distinctive because, except from Earth, no other body in the solar system has liquid bodies on its surface. Titan might be a living thing. Saturn's moon Titan, based on particular molecules in its atmosphere, may contain life, despite the fact that this may seem like one of the most improbable facts about Saturn. These substances have the ability to quickly initiate the fundamental chemical processes that aided the evolution of early living forms. These substances nonetheless have the capacity to produce life even though there may not be a direct indication of it. In addition, Titan boosts Saturn's magnetic field with plasma. Only the outermost portion of Saturn's magnetic field encompasses the moon. As a result, it is constantly exposed to the solar wind, which ionizes the moon's outer atmosphere and causes some of its molecules to separate from the moon's gravity. These particles are then attracted to Saturn in the form of plasma by the planet's magnetic field. Enceladus, the moon of Saturn, is almost entirely covered in ice. Enceladus is one of the solar system's most reflective bodies because of its ice cap. Enceladus has a lot of ice, which prompts researchers to hypothesize that it might truly resemble a comet in composition. This notion is strengthened by the discovery of ice volcanoes on the moon. There could be life on Enceladus. Enceladus has a lot of ice, which also means it has a lot of water, which is a sign of life. In addition to these ice sheets, researchers also take into account the likelihood of a subterranean ocean of water 10 kilometers beneath the south pole of Enceladus. The presence of intricate chemical molecules in the gases emitted by Enceladus ice volcanoes was also confirmed by the Cassini mission in 2018. Though common chemical processes could have created them, the existence of life on Enceladus hasn't been completely ruled out as of yet. Enceladus may have an impact on Saturn's radio waves, according to scientists. Saturn's radio waves are thought to be altered by the water vapor that Enceladus volcanoes spew into space. The water vapor's charge from static electricity has a small impact on the planet's magnetic field. The difference between the planet's rotation and its radio broadcasts can be tiny, despite the effect's subtlety. The most famous feature of Saturn is its rings. There may be rings on other gas giants, but Saturn's are the most distinct and well-developed of all of them. The inner edge of the ring is approximately 6,630 kilometers distant from Saturn and extends 114,070 kilometers into space. Additionally, researchers have discovered that a variety of chemical substances and water ice together make up the majority of the rings. Along with these substances, the crystals that make up the rings are lined with carbon from meteorites. The water content of the rings determines the variations in shade between different sets of rings. Scientists are still unsure about the origin of Saturn's rings. One of the most well-known features of Saturn may be its colorful rings, yet no one is certain of their origin. The origins of Saturn's rings are currently the subject of two major theories. According to the first explanation, the rings were created from the remains of a moon that had been shattered. The second idea contends that the rings were created from gas and dust that were left behind after Saturn first formed. They finally became trapped in Saturn's gravity and formed the planet's rings. The planet's rings are influenced by some of Saturn's moons. The ice eruptions on Enceladus, according to researchers, increased the amount of water ice in the planet's rings. The gravity fields of the moons Prometheus and Pandora also serve as counterbalances to maintain the ring's stability. Pioneer 11 was the first spacecraft to pass by Saturn. Pioneer 11 passed within 20,000 kilometers of Saturn's atmosphere in 1979. The probe was able to get many images of the planet and its moons, although they had very low resolution. However, it did succeed in getting the first precise observations of Titan's atmosphere. Saturn was reached by Voyager 1 and 2 in 1980 and 1981, respectively. Voyager 1 successfully transmitted the first ever high-resolution images of the planet, its rings, and moons to Earth. The probe also made a near approach to Titan, confirming that the atmosphere of the planet was totally opaque. Scientists were able to compare changes in Saturn's atmosphere from the previous year because to Voyager 2's additional photographs taken the following year. The most recent and effective mission to Saturn to date is Cassini-Huygens. The probe, which was launched in October 1997, arrived at Saturn in July 2004. The probe was designed to last only until 2008, but it actually ran until 2017, when it plunged into Saturn's atmosphere. During that time, it captured numerous images of the planet, its moons, and its rings. It also scanned Titan's surface through its dense atmosphere using a high-definition radar. Scientists were able to find Titan's hydrocarbon lakes thanks to the same radar. The probe also gathered thorough information about Saturn's rings using radio waves. Actually, there were two probes in the Cassini-Huygens probe. The orbiting spacecraft called Cassini was designed to remain in orbit and observe its surroundings from above. Later, Cassini sailed through one of the ice eruption plumes from Enceladus while gathering materials to return to Earth. Huygens, meantime, made the successful landing on Titan in December 2004, as he was always intended to accomplish. It captured up-close images of the moon's surfaces and transmitted them to Cassini for transmission to Earth. Later, Cassini captured images of the entire solar system. The Cassini probe's operators ordered the entire solar system to be photographed in July 2013. It was also a special occasion since NASA made their plans for Cassini to photograph the entire solar system, including Earth and the Moon, public. It was a celebration of life on the pale blue dot, according to one scientist who was a member of the Cassini team. Scientists were able to date Saturn's rings thanks to Cassini's final mission. The rings are just 100 million years old at their oldest. This indicates that although they precede humanity, their true appearance only dates to the time of the dinosaurs. Saturn has not had its distinctive rings for the most of its life. Future missions to Saturn are planned by NASA. The Saturn Atmospheric Entry Probe, SAEP, a robot designed to really enter Saturn's atmosphere, is one of NASA's ambitions. It would investigate the atmosphere's makeup and circumstances there, acquiring and transmitting as much information as possible before being crushed by the pressure. Currently, NASA predicts that SAEP will launch in 2027 and will reach Saturn in 2034. NASA intends to deploy a probe to Titan as well. This mission, codenamed Dragonfly, will make a robotic moon landing. Dragonfly's main objective will actually be chemical research rather than just capturing images of its surroundings. Scientists are hoping that Dragonfly will enable them to investigate Titan's chemistry and perhaps even the possibility of life. Additionally, Dragonfly is expected to include propellers similar to those found on drones, which would enable it to perform brief flights across Titan's surface. By doing so, researchers can examine more of the moon's surface as opposed to just a tiny region near the landing site. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.